All right, we are back on the opposite end of the turbine and generator. This is where the auxiliary oil pump discharge is going to tie in from the internal pipe, comes up through here. Another check valve right here. This is the main or primary oil pump. It is, sometimes we'll refer to it as the gear pump. It is shaft mounted to the turbine. If the turbine is spinning, that pump is spinning. I guess kind of go over how the two pumps interact. The auxiliary oil pump is going to be running prior to startup. It's going to get the oil up to the temperature we want. As the turbine runs up, this pump's going to spin more. It's going to start discharging more oil. When the turbine gets to, I think, 1550 RPM, the auxiliary oil pump's going to shut off, and then the primary oil pump is going to be discharging enough oil flow to fully take over. And then the auxiliary oil pump should only come on during operation if you lose lube oil pressure or speed drop. So on a shutdown, when it shuts down, the auxiliary oil pump's going to come back on at, I think, 1545. So, all right. Oil is then combining together. Discharge out through here, down. It's going to go to the lube oil skid, which has got coolers and filter. It's going to come back up here, in there. These are two relief valves. This is set, same pressure as the relief valve on the other side of the turbine, which should be 275. This one's set at 225, I believe, which is your control oil pressure set point the turbine wants. Right now we can see it's at 212. So it comes down in, this goes to the actuator, well, trip valve actuator right here, comes in. There's a little inline filter. I want to change that annually. The rest goes up to the three actuators on top of the turbine. Can't really see it from this view, but those are the throttle valve actuator. The oil then splits here. It goes to the oil regulator. This regulator drops it down from control pressure to our lube oil pressure. Right now we have it set 35 psi. The turbine wants between 29 and 54 psi, I believe. So we have it set a little higher than the minimum, but we run all of our other turbines around 29 and they've been fine. So no concerns there. This is going to go in, lubricate the bearings of the turbine, and then spray onto the gear mass. This side, it's going towards the generator. We've got a check valve here, and that is for the tie-in with the emergency oil pump, which is this line here. We've got another check valve, and we've got a little relief valve that's on the discharge of the emergency oil pump, and that's to knock the emergency oil pump discharge down to our desired 35 psi. Okay, then the oil is going to go up through the drive end to the generator bearing housing. We have a needle valve here that's locking, so you can't adjust it without a tool. You just use a crescent wrench, grab it, loosen it if you need to, but our target right now is 22 psi on that pressure gauge. And then there's an orifice downstream of that pressure gauge, and we want that pressure between 14 and 29 psi. It should be good at 22. We want it lower to prevent oil leaks, right? And we might want it higher if we were seeing that it was running hot for whatever reason, but it appears they'll all be running well as of now. Then goes on over to the non-drive end of the generator, and it's going to look the exact same. It's got a needle valve over there and a pressure gauge, and we want to adjust to 22 psi normally. We could talk about the coolers. So the generator has 4 cooler banks up on top. The generator has 2 shaft-mounted fans on the drive-in and non-drive-in that are circulating air through the coolers, cool it down, cools the windings in a enclosed loop. The coolers are all individually rated at 33% of your desired heating load, so you basically have 1 spare. We can determine which one we want to close off for now to be the spare, or if that's what you want to do, but you have extra capacity and you can utilize that spare. Let's see. That's a relief valve for the coolers right here, protecting from overpressure. Eventually, once the turbine is up and running and we've got a good load on it, we will want to throttle the outlet down there, and we're going to want to try and obtain a little higher winding temperature. I want to say around 200-ish. We'll see what it is right now, but I think we're going to want to throttle that back eventually, which is a slow process. You know, it'll be a small incremental adjustment and then wait a day and see what it does. Yeah, I guess I can go through the transmitter. So this is control oil pressure. This is lube oil pressure. Right here. This is gearbox vibration transmitter. The gray flex seal back there, that is one of your drive-in generator bearing vibration probes. Back over there, the 3 shining probes. Those are your magnetic hiccups. Yep, right back there. You got 3 of those. This voice block, this is what controls the throttle valves. So it is going to modulate oil pressure to the throttle valve actuators to open or close them. Yep.
Where's the inspection cover for the gear set?
Right there. There. Yep. Yeah.
Go ahead and repeat the question.
Oh. He had asked where the inspection cover for the gear mesh was at. Is right up there. Got 12 bolts, pull the whole plate off. If you pull the plate off, you know, be sure to clean everything before you pull it so you don't get a bunch of junk down on the gear. This preset or adjustable? So it is adjustable. We've got 2 potentiometers, like 0 and then 20, or 0 and 100. I did adjust it when I was here last week, and I don't know if you could hear it now that they've got the insulation, but you could hear it when I was here last time. You could hear it cracking because the steam started ripping through it. So I think we got it to where you could hear it cracking at like 4 or 5% throttle demand, okay, which was pretty good. And then I think once we were up at rated, it was sitting at like 8 or 10% throttle. Okay. And then this is a manual like testing knob, so don't pull that off during operation.
Woodward governor.
Yeah.
I also have a side beat thing.
Yeah.
Check to see if in fact it has control.
Yeah.
Wrap it up.
Yeah. So that should probably very much off limits when it's running. Probably be locked or something. Get a sight glass for the oil reservoir. Max, min, normal. There is a level switch on the reservoir that corresponds right below that min, and that will trip the turbine. So we want to probably put that on our daily or monthly check the oil level, but you shouldn't be losing oil. Really, the only time you're going to lose oil is during a filter change. This line is returned back from the Kydon lube oil filter skid, or oil conditioner skid is what we've been calling it. Yep.
I'm going to go and going visit.
See. Yeah. Trip valve. You can see the coupling in there. I don't know if Todd talked about that during operation, but when you reset the turbine on the control panel, if you lean back and look, you can see the coupling from the control panel. It's good to visually see that open up. So it's in a good position where you can actually do that as you're resetting it. Make sure that the trip valve is actually open and not hung up. Also the up here. But yeah, should be able to see this from the control, from the HMI when you're starting the turbine, and also when you're doing the trip simulation test on the local panel. Look over, twist the knob, watch it close, and then come back open. That's steam inlet RTD up there.
And all these, the temp probes, are they all dry wells?
Yes. Okay. Yeah. He had asked if the RTDs have thermal wells or dry wells. Yes, they do. So you can pull the instrument from the thermal well and not have to lock out the system. Speaking of RTDs, you can see the generator bearing temperature RTD, little black head down in there. So that's going to be the drive-in RTD. It's going to be the same on the non-drive-in side. Might need to go a little lower. Oh. Lower. Oh, come right here. And then up. Angled down at that. There you go. Right there. Yep, that's it.
The mine got it.
Got oil drain temperature. Monitor that. I would expect to be a little different between the drive-in and non-drive-in. We also have a little breather back there. And then you have a sight glass here, just to verify that there's oil flow. It's going to be the same on the non-drive-in. All right. Well, I think ready to go down to lube oil skid. Over there? Yeah. Well, actually, touch on these real quick. Kind of hard to see, but yeah. All right, so we're just going to go over the condensate drains on the turbine. We're going to want to, all these, I'll just go through them and individually point them out. All right, so this one nearest us, this is just going straight to atmosphere. There's no valve on it. This is a packing gland leakage. Yep, for the trip valve. Comes in right there. Okay, our next one is our live steam connection. So that comes up to the bottom of the, I guess, trip valve housing. We will want to open the bypass valve around the trip valve downstairs for warm up to get steam flow in through the inlet piping, warm it up. We're then going to have two nozzle block low point drains. Those are going to have steam trap and bypass valve. Good to keep those the bypass valves cracked open at startup. Once you're up at rated speed, got a little load on the turbine. Could be able to close them down comfortably. Verify you're not getting a bunch of water coming out. This one is our low point exhaust. We'll want to keep that one open up until we get to rated speed, the bypass that is, and then you can close that down and let the steam trap take over. You then have another vent that's just going straight to atmosphere, and that is off of the carbon ring packing gland. So that will always stay open. And that is it for those.